April and Capangpangan. Today, we are going to talk about what is PR spectroscopy. First, we discuss about spectroscopy. So what is spectroscopy? Spectroscopy is the interaction between matter and radiated energy. It also deals with the light. Spectroscopy analysis has been crucial in the development of the most fundamental theories in physics, including quantum mechanics. It is also applied to high-energy collisions and the key tool in developing scientific understanding not only of the electromagnetic force but also the strong and weak nuclear forces. Spectroscopy techniques has been seen in many fields of science and technology. For example, microwave spectroscopy has used in black body radiation. Radio frequency spectroscopy has been used in medical technique, not only to mention the X-ray spectroscopy that we are very familiar with. These are the various applications in this characterization, but we are going to focus on the optical spectroscopy, which routine is to identify the chemical composition of matter and determine its physical structure. Photoreflectance energy is an optical technique for observing the electronic properties of thin films. It measures the change reflectivity of a sample in the application of amplitude-modulated light beam. In general, PR spectroscopy consists of the intensity-modulated pump light beam. This is typically modulated in known frequency, so unwanted noise can prevent. The conventional photoreflectance apparatus uses a spectroscopic source for the probe beam. The signal may be written as lambda r over r equals alpha delta sub E1 plus beta delta sub E2, where the delta r over r is a normalized change in reflectance and the alpha and the beta are the Seraphine coefficient. So let's get to talk about the origin pro and the electric field.
Origin is the data analysis and graphing software of choice for over 500,000 scientists and engineers in commercial industries, academia, and government laboratories worldwide. Origin offers an easy-to-use interface for beginners combined with the ability to perform advanced customization as you become more familiar with the application. Origin graphs and analysis results can automatically update on data or parameter change, allowing you to create templates for repetitive tasks or to perform batch operations from the user interface without the need for programming. First, you should have the software installed in your device. Then, a workbook will appear where you will put the data you want to have a plot. Origin Pro allows you to create various plots, but for this case, we will be creating a line plot. With the generated plot, this can be smoothened to yield a better plot for determining the extrema, which will be used later for the linear fitting. From the photoreflectance spectroscopy, a plot can be generated using the photoreflectance intensity and energy of the material. With the use of Origin Pro, plotting is possible, and other processes can be done such as smoothing of the plot, determination of energy for each FKO extremum, and it provides the slope and y-intercept of the plot. With the smoothened plot, we will now determine the FKO extrema, which indicates the presence of the electric field in the material. Yielding a linear result can be the basis of whether the FKO extrema you have set is good or acceptable. Origin Pro has a tool that gives you the value of a certain point. Determining the values for each FKO extremum is imperative for the linear fitting. Another plot should be generated for the energy of each extremum with respect to the quasi-index f sub j. Upon the process of linear fitting, values will show up containing the slope and y-intercept of the plot, as well as it will tell us if it is linear by the r-squared 5. Proceeding to the calculation of electric field. After the linear fitting, we will be able to get the slope of the plot, which is needed for the calculation of the electric field. Like what was mentioned earlier, from the values of F sub j and energy of each extreme, we can perform linear fitting for the linear regression plot. And from that, the slope can be obtained and be used for the calculation of electric field, which is given by electric field is equal to slope raised to 3 over 2 times 8 mu over e squared h bar squared raised to 1/2. So substituting the values will lead us to the electric field of the material. But take note that all of the constants must be in the same units. There is a line that indicates the Fermi level, which is the horizontal dashed line. Keep in mind that the location where you will mark the Fermi level is crucial because it determines on which side of the heterojunction most of the band bending occurs. So one thing to consider is what semiconductor is heavily doped. The Fermi level is marked with respect to the flat band edge of the heavily doped material. But in the case of a nearly equal doping levels, the Fermi level must be drawn close to the middle of the distribution of flat band points like what is shown in this figure. So after putting an indicator for the Fermi level, we will do the same thing we did earlier, which is to mark the band edge positions relative to the Fermi level based on the doping in each semiconductor. We can see here the valence band energies and conduction band energies of each material, which is denoted by E sub V and E sub C. So the values here depend on the doping of the semiconductors. For this case, the band edge positions for the gallium arsenide can be located near the Fermi level, and the other one is aligned with the band edge position of aluminum arsenide. Before doping and for the aluminum arsenide, the band edge positions are shown in the figure. Lastly, this is where we connect the band edges far from the junction and the band edges based on doping. But for this step, there are requirements must be met, such as the slopes of the connecting segments must match where they intercept to the points to satisfy the electrostatic continuity equation, and the depletion rates are fixed by the doping levels.